All right, hello everyone. We're going to move on in our circle unit. So if you want to find page 14, this is section 10.5. The topic is called Apply Other Angle Relationships in Circles. So you might pause that so you can get that written down. I actually have a warm-up for you. I want to review a topic from last section. All right, so I would like you to pause the video. You are given this circle with the inscribed quadrilateral, and I'd like you to find the values of x and y. So go ahead and pause it. Grab your paper, notebook paper, or use the notes paper, and I'd like you to work it out. So go ahead and pause it, and then come back when you have your answer worked out. Okay, I have here, first of all, let me move this out of the way over here. So first of all, the answers are 8 for x and 4 for y. Now, the one thing that tends to be tricky is that our opposite angles are not congruent. So in parallelograms, they are, but this is not a parallelogram. This is just a quadrilateral. So in order to inscribe a quadrilateral in a circle, the only way that it'll fit is if these opposite angles are supplementary. So when I do that, I have to write both equations out, and then notice I have a system of equations. So I used the elimination method. I made my two x's turn into negative and positive 24, and then I'll leave this up here. You can see I solved from there. Okay, so that's one thing to keep in mind. This is a much more challenging inscribed angle or inscribed quadrilateral question, but it does fall into just kind of reviewing that algebra. So, okay, if you want to look at this longer, pause the video. Otherwise, I am going to move back to our section and we're going to get started. Okay, we have a number of theorems here, and so our goal or our topic for today is all about angles that are formed with various tangents, tangents and chords, basically. Okay, so first of all, our first theorem is talking about a tangent and a chord. So the theorem says if you have a tangent and a chord that intersect at a point on the circle. Okay, so here's your tangent on the outside. Of course, your chord's on the inside. They are intersecting right here at that point on the circle. When that occurs, notice we've got angle 1 over here created an angle 2. So then the measure of each of those angles formed is half of the measure of its intercepted arc. So let me try to see if colors show up here. So angle 2, all right? So this arc I'm outlining in blue is the intercepted arc that is formed by the connection of the tangent and the angle and the chord. So what this theorem is saying is that number 2, the angle measure here is half the amount of the arc. All right? On the other side, let me do red. This is the intercepted arc that creates angle 1. So the arc itself is, the angle is going to be half the amount of the arc. Okay, so like for example, if this arc is 100 degrees, this angle is going to end up being 50. Okay, and let's stick with those numbers. So if that arc is 100, and I know that an entire circle has 360 degrees, that means that leaves 260 degrees on this arc, okay? And so if you take 260 and you divide by 2, this arc is this angle, excuse me, is 130. Now, I also want you to notice that, take the circle away, but keep the chord and the tangent. Look at the relationship between angle 2 and angle 1. Okay, if I keep my tangent, let's say that's my chord. I've got angle 1 and angle 2. Okay, these are a linear pair. They're supplementary. So notice that 130 and 50 adds up to 180. Okay, so that relationship is still there. It hasn't changed. We've been studying that relationship all school year. So that's another way you can help yourself find missing angles. Okay, let's look at the first couple examples. All right, line X is tangent to the circle. There's line X. Find the measure of angle 1. Okay, let me switch to red. I think that shows up better. All right, so according to our theorem, the arc I'm outlining in red is the intercepted arc. It has a relationship with angle 1. So angle 1 is half the amount of the arc. Okay, so I'm going to say here that the measure of angle 1 is equal to 1/2, and I'm going to go ahead and just put in my number, 1/2 of 220. All right, so if I take half of 220, I get 110 degrees. So therefore, the measure of angle 1 is 110 degrees. Okay, I want you to try letter B. Go ahead and stop the video and see what you come up with. Okay, on this one, I'm finding the arc I'm being asked to calculate. So EFG is the arc I need to find the measure of. And it has a relationship with this angle. Okay, so that I do have the correct angle. So if I took half of the arc to get to the angle, well, I can do the opposite to go from angle out to arc. So I'm going to take my 135 and I'm going to be able to double that. All right, so that means that we will get a 270 degree arc. So the measure of arc EFG is equal to, what did I say, 270 degrees. Okay, so make sure you look at the measure between those two. All right, there are 3 more at the bottom. I'd like you to try those 3 on your own, and when you get finished, come back to the video, or if you get stuck, feel free to come back and take a look as well. Okay, first one, I need to find the measure of arc PRQ, so I outlined it in red. It has a relationship with 113 right here, so I'm going to double 113 to get to the arc. Okay, and so therefore I would get 226 degrees for that one. Okay, measure of angle 1 is going to have a connection with this arc. So I'm provided 164 here. If I take half of 164, I get 82. Okay, last one, measure of arc XZ. So which way do I go for arc XZ? And so when you start to look at it, look at this 90 right here. If this is a 90-degree angle, then if I double it, I get a 180-degree arc, which tells me that that is a semicircle. So it doesn't matter which direction. This is also 90 because it's a linear pair. So I end up with 180 degrees for that arc. Okay, so that's rule number 1. Rule number 1, I would say, is that the angle itself formed by a tangent and a chord is 1/2 its intercepted arc. All right, let's look at the next couple of theorems. So the next couple of theorems, in fact, that first one didn't have a name. These two have names, but honestly, I'm not sure. I feel like the names are kind of confusing because if you look at the two names, we've got angles inside a circle theorem, angles outside a circle theorem. And I guess they're not super confusing. I mean, they describe where the angle is. Angle 1 and angle 2 are inside a circle, and then angles 1, 2, and 3 are outside, which you can remember the names. I'm just going to refer to them more as concepts. All right. If two chords intersect inside a circle, of course you can see I've got 4 angles formed, then the measure of each angle is 1/2 the sum of the measures of the arcs intercepted by the angle and its vertical angle. So let's use some colors again here. All right, so angle 1, I'm going to kind of darken in blue. So I want you to find the arc that goes with angle 1. So arc DC right here is the intercepted arc of angle 1. And then the vertical angle to angle 1 is where I put my blue dot. Its intercepted arc is AB. All right, so I kind of look across my circle. So this is saying, and this is really an average we're looking at. So the measure of angle 1, and that's our first line here. The measure of angle 1 is 1/2 of arc DC plus arc AB. So I'm going to add these two blue arcs together and divide by 2. So this inside angle is really the average of the two arcs. Okay, add them up, divide by 2. Okay, number 2, I'm going to kind of darken a little bit in red. So number 2 goes with, or it's really an intercepted arc, BC, and then number 2's vertical angle is right here. And this red arc is the intercepted arc of the vertical. So angle 2 is the average of the two red arcs. So the second line here says that the measure of angle 2 is 1/2 of the measure of arc AD plus the measure of arc BC. Okay, so I can add these up, divide by 2, add these up, divide by 2. Now you still have angle properties we've studied. Vertical angles are congruent. Okay, I have a linear pair. 1 and 2 are a linear pair, so that might help me as well. Okay, let's move on to example 2, okay, before we look at the second theorem. All right, example 2 here. Find an angle measure inside of a circle. So find the value of x. So I'm going to start with x. Red arc is the intercepted arc of x. Its vertical angle is this other red arc. So the theorem says if I take half of the sum of these two arcs, I get x. So I'm going to say here that x is equal to 1/2 of 85 plus 57. Okay, so if I do that, if I do 85 plus 57, I get 142. Okay, and then take half of that, we get 71. Okay, so x equals 71. So there's two ways I could find y. Let's stick with the theorem first. So angle y, or y degrees here, goes with this arc that's blue, and then its vertical angle goes with the 70. So we can say that y is equal to 1/2 of 148 plus 70. So 148 plus 70 is equal to 218. And then take half of that, I get 109. Okay? Now, I could have also said, well, x and y are a linear pair. So if this one is 71, what is its supplement? Or what's the value to get up to 180? So if I do 180 minus 71, I get 109. Okay, so then I could have maybe skipped the circle theorem on that second one. Okay, I'm going to stop video number 1, and we're going to then pick back up with the angles outside the circle theorem, and then wrap up a couple of more examples.